Hi everyone, my name is Nikodem Tadrowski. I am a machine learning engineer at DeepSense AI, and today I would like to showcase Dash applications from beginner basics to production-ready code. So what we will talk about is like a problem statement. So what are the things to consider when you try to develop web applications, especially dashboards for the clients? Then we will go through the introduction to Dash tool and show what are the components of it. Then we will go through the most common mistakes in Dash that probably throw you in some pitfalls when developing. Then we will talk a little about open source versus enterprise version and what it is. And then we will have some examples of production-ready code and solutions that are probably useful. And at the end, we will have a brief summary. All right, so what is the problem statement? We would like to develop an interactive dashboard and showcase some models' performance and probably give some interactivity for the user to filter on those. So what do we need to have in mind is like user experience and interface design, data integration and real-time updates, customization and personalization. So those 3 points are like really important and probably set a trademark for the company. So if this needs to be a front-facing stakeholders dashboard, then you probably need to follow the guidelines for the design and ensure that everything is aligned with what the company has in mind. What else do we have? We have scalability and performance, as well as security and access control, which are also common topics like how many users will you have, who and where should have an access to, and so on. So what underlies under those steps? It's like infrastructure, backend, frontend, and those are like our trio to consider. So there are a lot of buzzwords on this slide, and modern frameworks for developing applications probably hide most of those for you, providing you with ready-to-use components to skip like the manual part of the job that you want to do. But regardless, you still need to know like what kind of infrastructure does the client have, and if they want to, how would you like to maintain your application, and so on, and what languages would you like to use to develop your application based on the team's experience with tools, and so on. All right, so what are the options for Python developers to build interactive web applications? So if you Google what can be the best framework for for developing applications, it will probably be Django, because it is a well-established framework, full stack framework that is like the tool for everything, that includes like all the necessary tools for creating a real web applications that are like thought through and are like fully fledged projects for huge audience. So it's not probably the best tool for like interactive dashboards that will be only for the stakeholders, which maybe you have 50. It's also not good for like minimal setup projects, because like there's all batteries includes in the Django, so you probably will skip a lot of the parts that you could use in the fully fledged app. Then there's also the requirement of using JavaScript for the front end, because usually you have like a static pages and need to reload anything to send out the forms. So what other options you have? Then let me introduce you to like 3 lightweight frameworks. First one is Gradio. Gradio was like developed for quick prototyping and showcasing your AI ML models. It's really easy and simple and provides like reactive components. However, it's like not a modern tool, That is, it lacks of custom components or like restricts you to a tile-based layout. Also, there are like no means to implement some user authentication or any other infrastructure things. So what else do we have? We have a Streamlit, which is like a modern-looking framework. It has like high-end layouts, high-end visuals. Requires minimal setup. However, all the Streamlit apps are the same because it's like a single page template that you can use. That is like left bar for choosing the page that you would like to run, and the right hand field for like showcasing your visuals. It is also restricted, so if you want to have some custom CSS, it's really hard and you will probably need to hack in those. Then you have Plotly Dash, which is like a framework that was built on top of Plotly.js, which is also a well-established JavaScript framework. It is fully customizable. You can have your own server definition, which will help you with like infrastructure-wise. It is rich in components ready to use out of the box. It has a lot of extensibility with custom components that are ported through React known packages. The cons of this solution is that it's hard to maintain because there are like a lot of pitfalls that you can fall into if you just develop from the examples on the internet. And the other thing is that the infrastructure things don't come up out of the box, so you probably will need to manually set up server and authentication and so on. So let me introduce you like what are the key features of Dash. So it's built with on the backend, it's built with Flask, Plotly, and React. On the front end, it uses React components for reactive UI elements, and all are controlled via Python. That is, you describe the React code with the Python. So what it entails, it can be pure Python, so no need for JavaScript, making it easier for data scientists and analysts. It's interactive and reactive. Single-page architecture allows for automatic updates of UI components without reloading the pages. It has a lot of built-in components like plots, tables, and controls ready to use with wide range of parameters to adjust those. It is community-driven and has a plentiful of resources due to its popularity and because it's based on Plotly.js. It is enterprise-ready solution because it's scalable, deployable, and integrates well with datasets and APIs. So is Dash really simple? So there are usually 5 steps to achieve something that would be a reactive application. On the right, you can see there is like an input field, and whenever you write anything, it will already be reflected on one of the HTML components. So what did we need to achieve that? You first need to import Dash and its components. Then you will define your app instance, which is the Dash application running server. Then you have layouts with 2 components, that is the title, welcome to Dash, and the input. Then you have callback, which will pass the data between input and output and create perform some operations defined by the user. And on top of it all, there is the run application clause, which will start the server. So what are the layouts that we have seen? The layouts are the definition of our HTML code. So it is possible to use Jinja2 templates because, as you've seen, the Flask is underneath the Dash. So, but this solution is not like great overall because of like a lot of, you will need to customize with CSS and bootstrap everything by yourself. And it is only useful when you would like to have like a server side, which is a Flask side operations performed. Then you have a Python code definition, which is like the definition of layout through ready-to-use components from either the Dash Common Components library or Dash Bootstrap Components library, which translate and perform all the operation of applying Bootstrap, applying appropriate class names, and so on with ready-to-use components. And what is a page registry? That's also a part of the layouts. It allows you to create, define pages with parameters. What does this entail? It is like easier for the user to, for the developer to restrict the access to certain endpoints or layouts, as well as define a dynamic endpoints for the application based on the role access. All right, so what are the callbacks? So the callback defines a function that will ingest inputs, states, and at the end it will return an output. So output is a ID and property of a layout elements to be updated. Inputs are IDs and property that will trigger the update, the underlying function. And the states are just the states of the elements and do not trigger an action, which is helpful for like storing some parameters and not refreshing as frequently. There's also a possible definition of initial action, so that to prevent initial call of the function, because by default it is always running the underlying callback whenever all the elements in the layout are available. So there can be two types of callbacks, server-side and client-side. For the server-side callbacks, you will perform the action as a server, and you will define all the code in Python. What that means? It means that you have access to any resource on the server that is available, and you can directly pass the data from the server to the client and from the client to the server. For the client-side callbacks, you don't have the access to the server, and you are performing the callback in JavaScript because you are doing it in the front end. What it entails is that it is a lot faster because you are not passing like, for example, 5 megabytes file to be tossed around between server and client and rendered properly. So there are also advanced callbacks because the output inputs would not be enough. And if you would like to create a form, then you will probably fall back into having like a 20 parameters function, which is also not optimal. So what can you do? You can structure your inputs, states, and outputs so that you ingest a dictionary or list or any other data type that is supported. That way you can reduce the amount of parameters and have a ready-to-use form. What else? You have pattern matching, which allows you to select all the components that have like a specified type, index, or any namespace that you defined. What else? We have background tasks. So you can launch your code asynchronously using Diskcache or Celery, which would require you to install additional packages, but those are helpful for long-running tasks because the callback has like a 30-second timeout if it did not return any result. So there are also like running parameters so that you can define elements that will be disabled during callback, or you can define an interruption input that will cancel the action. There are also external components that I've showcased before. So the basic features in Dash are okay, Those lack in modern UI styling and data tables handling. On the right, as you can see, you have like a standard table that is not pretty beautiful. You have line by line code, I mean the blocks, so you also would need to write a custom CSS to align those, and no one would like to center a div. So what else can you do? You can use Dash Bootstrap components to achieve the right look. So you can use navbars, you can use like a tiled components, you can use themes that will change the look of your application without like some special definitions in your CSS. And it allows you to like achieve better aesthetics. So why did the table change? We've used the Dash AG Grid library, which is like built on top of JavaScript. It is like very popular in the React community. It has fast modern rendering. It allows for editing and customization of your rows and tables, as well as like provides rich animations that will help you distinguish between what has changed when you sorted the table instead of re-rendering full data. All right, so that would be all for the initial introduction to Dash. So let's see what are the most common mistakes that can be your pitfall in maintainable code base. So if you develop by Dash examples, you will probably end up with like huge files without the possibility to like look around or like have 10,000 lines of code and you don't know what is happening and you are restricted to adding new features. So what can you do? You can split the definition of the callbacks, the pages, and the server itself. On the right, you can see that there are like assets for your custom elements that will be used. You have your applications, which are your callbacks defined for each page that you have created. You have your configuration files. Those would be probably your Flask files to create some custom predefined configurations to the endpoints and so on. Then you have pages, which will be your pages definition, which are layouts for each page that you would like to showcase. Then you can take out some common components or the components that will be rendered on every view. You have your utility functions, and then there is like an app definition, which will contain all your server definitions. So the other mistake that you can make is like relying only on your own CSS. So it works. You probably have some knowledge. However, it like is also not maintainable due to like it's your own style. You know what you did, but the next person probably is not aware of what was used and why it works that way. So here comes the Dash Bootstrap components, which will allow you to unify your styling and do not care about like custom development of those. So the other bottleneck in your application is probably due to too much loading. What does it mean? It means that you probably load, like in the top right example, data with each callback function. I mean, if it's a huge file, then you probably need to wait like 5 seconds for it to be passed to the front-end client side. So that's not optimal. What can you do? You can load the commonly accessed files with caching on the bottom right corner so that you create a custom load function and just load the data that way. That works. It's especially useful if you want to load like over 8 megabytes file size, because that's the limit of like client storage. And if you store anything bigger, then you will need to wait for all the data to be passed in chunks. That's also why storing large objects in DCC store is not optimal, because you can hit the limit and will introduce like a very big lag. So not using callback graphs. So what are callback graphs? If you launch your application in the debug mode on the bottom right corner, you will see like callbacks, errors, and server statuses. So if you click on the callbacks, you can see that you have an access to overview of how much data do callbacks pass, how much time it took to all the data to be passed to the server, or how many call counts were initiated after some callback. That is really useful when you have an application that starts to randomly, for example, refreshing your data even though you didn't click anything, which sometimes happens. So the other thing is like not testing the application. Since Dash 2.6, we can test our application with built-in testing framework. So the approach here would be to create standard unit test on callbacks so that you have your mocked data as an inputs and check if the outputs, like outputs your graph or any other filtered data, and so on. The other approach is to use custom end-to-end tests on the code based on WebDrivers or Selenium grids. So underneath, it wraps around like Selenium and allows you to perform standard actions, which is launch the server, check if the data is available on your website, and if it is, the test can pass. It's really useful, and I didn't see like anyone using that. But like if you, there are maybe because there is like not much information on the internet about this, but the documentation is plentiful of information, and you can easily create your tests. So that would be all for the mistakes. Now let's talk about open source versus the enterprise version. So the main difference is that the library -Python is an open source free-to-use library, and it is not a product. Whereas the -Enterprise is a real product that will cost you money, but it allows you to have a dashboard to build your dashboard. What I mean by that is that you can define there all your necessary like user management stuff, your UI development, so that you can use ready-to-use components and just drag and drop them. You have integrated CI/CD security features and authentication out of the box for all the platforms. And you have managed hosting and support from the Dash team themselves. In most cases, you will probably look into -Python open source version and not bother with -Enterprise. Right. And if you would like to have a specialized team working on your project, then you should probably take the -Enterprise version. So what are like some production-ready code bases that I will talk about? It's like how to deploy Dash application on cloud with secure authentication, because this is like the most basic but important idea when sharing your application with stakeholders or any other people that would be part of the team. So we will use like an Entra ID for secure authentication configured with Microsoft account, which will allow us to create like a login page, restrict some endpoints, create like a application that can be shared with audience, and restrict components by the role. Then the other thing is that I will showcase the scalability of your project. So you have either an approach with multiple Dash applications or multiple page Dash application, which is a single application. Both solutions can be easily deployed on cloud. Both scale in a different way, optimize experience for the developer, and allow for reusing components when creating your applications. So let's see the demo for the first authentication. So as you can see, I've clicked login. I passed through the authentication with Microsoft. I confirm all the data, and here we are. We are back to our example, and we have like basic information. Welcome to Dash, and my name that was taken from the authorization server. So so how to set up such authentication? So you need to know that the definition, the order of the definitions matters, because we need to customize our Flask server, then the Dash application. It's possible thanks to like Dash being built on top of Flask. We use for authentication the Flask sessions plus identity library. We could also configure like our proxy or like use server standard Flask objects for the configuration. So on the right, you can see that we have first like server definition, then our authentication definition. Then we can create the check before each access to endpoint that we will go, push the user back to login page if it is not available. If he's not logged in. And then we have like a Dash server definition with the server of our custom Flask server. So what is the flow here? The important thing is that you need to do all these operations on server side, which means that you need to use Flask and render the template. It won't work if you would try to use Dash side operations, because those are dynamic and you will never be able to get the session cookie back, because with each transition you are refreshing all your states. So that will be all for that one. Then I would like to showcase like multiple Dash applications approach. So what you see here is that you have two applications that you can access, each on a different endpoint. And what does this entail? You have like your structure. It's good for like a simple dashes, like displaying maybe one or two figures and having some basic filtering. It allows you to scale all the data through single page applications, defining all components in a single file, which is like a good practice only for really small projects. Unfortunately, this solution does not allow you to use the multi-page Dash application, because it's now managed by Flask instead of the Dash. So yeah, that would be that one. You will also need some like a dispatcher to control your access points through like web server gateway interpreter. So what is the multi-page Dash application approach? You have like the top navbar, and you can define your endpoints to be accessed through like Dash. What it does, it's faster. However, all the callbacks and all the pages are preloaded. What does it mean? It means that you have like if you define the same component on the different layout from the callbacks are global. So that means that you will end up with something that could potentially launch even if you didn't like invoke it in the particular app or page. It's not optimal. However, it allows you to share the data between the endpoints and, for example, select a simple select your pipeline and go through all the components of your dashboard. That is like model performance, model insights, or anything you create. The approach is pretty simple. It imports all the callbacks, imports all the pages that all the layouts that need to be registered as the pages, and you have your definition of server, authentication, and app, and you create a separate file to launch your application to avoid circular imports. So that would be it for like the production wise. And then we can skip to what we learned today. You can build high-end interactive dashboards with Dash. Just use external libraries like AGGrid for adding data tables. Look often into callback graphs to resolve any choking points of your interactions. Then you need to separate and standardize your components and pick a proper multi-page or multi-layout, multi-page or multi-application approach to ensure robustness of your code. So use standardized components from Dash Bootstrap components and try to build templates for easier management of your dashboards. And last, one of the most important ones, test your application properly. Do unit test for your application with PyTest and simultaneously write end-to-end tests for your pages. So that will be all from my end. Thank you for your attention.